Assalamu alaikum wa rahmatullahi wa barakatuh. We'll be starting soon. I request you to please keep a copy of your slides. I'll not be using the slides today, so we'll just be referring to them. So if you have a copy of your slides, it will be easy to follow. So what did we do in the last class? We looked at different operators again. So we looked at the NOT operator, we looked at the AND operator, we looked at the OR operator, we looked at the implication, we looked at the bidirectional operator, and we had also looked at the XOR operator. Can you all see the whiteboard and my writing on it? Okay, good. Okay, thank you very much, Hisham and Ali, for that response. Okay, so we had also looked at the truth tables. We looked at the AND truth table and lots of truth tables. Okay, now let's look at this. We know the truth table for P or P and Q. It's very easy. So we have P, Q, and P and Q. So what are the different values that P and Q can take? They can take true, 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 false, false, true, and false, false. So what are the truth values? True and true is true, true and false is false, false and false. Okay, so this is clear, right? This is something that you have done previously. Now let me complicate this a little further. I want to know the truth table for this. Okay, I want to know the truth table for P and Q or P. So I just create a new column. I say this is P and Q or P. Okay, and start filling in the values. True or true is true. Oh, very good, mashallah. Very good, Ali, Hisham, very good. Okay, so false or true is also true. False and false is false. False and false is false. Okay, true, true, true. Thank you very much. Thank you for reminding Abdurrahman. I always forget this in most of my classes. So I request the students to remind me to start the recording. Thank you very much. Okay, so is this table clear? Okay, let me give you a complicated portion then. I want to know the truth table for this. Yes, Hisham, it's easy. I'm just making it sound like it's very complicated. I'm just making it sound. Okay, so try to do this and tell me the answer. So you can have the first column is P, the second column is Q, and probably the third column is not P, so you're not confused. And then we have not P or Q, and then finally we have not P or Q and Q. Okay, so please fill this out. I usually write it as TT, TF, FT, and FF. So this is up to you. Okay, you can start off with false, 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 true. It's up to you, but try to maintain consistency. Make sure all four are covered. Okay, so try it out and tell me what the last column is. The only mistake you can make here is a silly mistake. So go slow, don't rush. Go slow, and you'll be able to complete it. Complete it correctly. So do it slowly. Complete the not P column. So I'll help you with the not P column. The not P. So true, this is becomes false. Again false, true, and true. So P and not P. I just look at the first column and then fill the third column. Okay, now to fill the fourth column, you look at the second and the third column. So we have TF, we have TF, one of the student, we have TFTT, TF, most of them, we have 3 TFs. Okay, which of these is correct? TF. Okay, Yasser, Sultan, Ali, Firas, very good, very good. Okay, let's see which one is correct. So let's fill in the fourth column. So not P or Q. So we look at the second and the third column. True or false is true. False and false is false. True and true is true. False and true is also true. Okay, let's look at our answer. Okay, so this is the fourth column and this is the second column. So we have to do 4 and 2. So true and true, true, false and false, false, true and true, true, false and true, false. Okay, so we have a TF. Is that clear? Very good. Okay, so this cannot get any more complicated. It cannot get any more complicated. The only thing I can have is instead of Q, I can have a not Q, or more operators, and that's it. Okay, this is a simple problem. This is called the truth table, filling it out with the truth table. So we can fill it out. Okay, let's take another example. So I said in the last class, I said if P then Q is equivalent to the contrapositive. Okay. When are they equivalent? We say they are equivalent when their truth table is the same. If the truth values of the left hand side is the same as the truth values on the right hand side, we say that these are the same. So how do we find out? Again, we have the column P, we have the column Q, we have if P then Q. We know the truth table for this based on our previous lecture. Then now we want to look at the right side. To look at the right side, we need some more operators. We need to find out not Q, what is not P, and then based on this we have not Q is okay. So can you do this? We have TT, TF, FT, and FF. Okay, so we know the third column. Third column based on our slides is TF, TT. Okay, so fill it out. This should be the same as this. If these two columns, the third column and the fourth, fifth, sixth column, if the third column and the sixth column are the same, then we say that they are equivalent. Try it out and let me know if they are the same. Okay, mashallah, some of you have already done it very fast. Hisham and Abdullah Hassan, Abdullah Khalid, mashallah, very good. Try it out, others, and let me know if they are the same. Yasser, Sultan, Firas. Okay, so let's fill out the not Q. Not Q is just the opposite of Q. And not P is exactly the opposite of P. Okay. Okay, now how do we find out it's the same? Okay, we have if something, then something. Yeah. So if something, then something. So here we have false, false is false. False, false is true. True, false is false. False, true is true. True, true is true. So we find it's the same. Yes. So all we have to do is we can think of this as P, think of this as Q. So here this will be P, this will be as Q. Okay, so generally we have, think of this, if something then something. This can be any variable. It can be any variable. Any variable. Okay, here we have it as not Q and not P. So these are the two variables. We know the variable this, the truth value of this, we know the truth value of this, and we just solve this. Is this clear? Okay, very good. Okay, the only confusing part is the Q and P are reversed over here. So you might think that it's different, but think of it as if something, then something. Okay, for example, it doesn't matter if I have an and operator, regardless of what this is. This can be not A and B and C. So if I have something like this, I need to know the truth value of this. I need to know the truth value of this. So the truth value of this, truth value of this. Just using a simple AND table, I can solve this. These are just variable names. Okay, so for most of the problems from now onwards, when you see this operator and you see a big expression here, okay, so this whole thing is something. Find out the truth value of this, find out the truth value of this. So once you know the truth value of this and this, it's very easy to find the truth value of the complete thing. Okay, although it's a complicated expression on the left hand side or complicated expression on the right hand side, this basically, if this is true and this is false, the resultant is false. Okay, so you break it up systematically. Is that clear? Okay, we will take an example just to make sure that we have understood it. So I'll give you a slightly lengthier expression. Okay, so we have not A or B, so I have A and B. So please find out the truth value table for this. Find out the truth value of this. Yeah, so we have true, 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 false, false, true, true, true. So it's up to you how you create the columns. You can create it as you wish. So some of you might do this. Third column as not A, fourth column as that. Some will directly jump to the fourth column. So it's up to you. But be careful because you might make mistakes. So having an additional column is always helpful. All true. Yasser says all true. Any other answers? Yasser says no, wait a sec. Okay. That's the problem. Some of the good students they rush because it's very simple. They try to do it very fast and they make one small mistake. So we have false, true, false, true. Okay, two false, true, false, trues. So we have false, true, and false, true. Any other answers? Ali Habib and Firas. False, true, false, false. We have a false, true, false, false. Any other answers? Go carefully. Don't jump, don't make mistakes. This is a 10 marks question. Very 10 or 8 marks. You'll have this in the final and in the midterm. So, guaranteed 8 marks or 10 marks. False, true, false, true. Sultan also says it's false, true, false, true. Okay, let's try. Not A. Not A is true, true. Not true is false. False, true. Ah, the last is false, false. I'm sorry. This is false and false. This should be false and false. I'm sorry. I made a mistake here. I hope you haven't made that mistake. Okay, so not A or B. So this is true, false, true, false. Not A or B. That's third column or the second column. B or A. B or A with the first two columns. True, 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 false. And then we have not of that, which is the opposite. False, 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 true. And the last one is this column and this column. So true, if true, then false is false. False, false is true. True, false is false. False, true is true. Okay, FT, FT. Very good. So this is the answer. Yes, bottom left is F. Both are F's. Last one is not A, is T. Which column for us? or Ali Habib. I'll just open up your mics so you can tell me. Firas. Firas, I've opened up your mic. Firas Al Hilali. Yes, Firas Al Hilali. Can you tell me what?
Yeah.
Yeah.
In the third column, you made a mistake. Last one is T, not F.
Last one is T. Very good. Yeah. Thank you very much. So this is not T, it is F. So F and F is F. It's T, right? Okay. And then the fourth column becomes not A or B. So this also becomes T, right? B or A is false. Okay. So we have a true and true as a true. Okay, thank you, Firas, and thank you the others who pointed out. It makes me very happy when someone tells me there's a mistake in my calculation. The objective is for you to understand, and if you correct my solutions, which means you have understood. So thank you very much. Okay, so is that clear? Is that clear? Everyone, anyone wants to say something? So this is the most complicated I can think of with two variables. Okay, now let's move on. What if I have three variables? If I have three variables, A and B implies P. Okay, I have three variables. How many rows will I have? How many rows will I have? For two variables, I had four rows. For three variables, how many rows will I have? In the truth table. So I have 8, 5. Any other answers? Okay, let's write it down. We have A, B, and P. Okay, it's very important we write that. Okay, A, B, and P. Yeah. So I will have 8 rows. You can think of it as a binary. So 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. Okay, so I have 8 to the power of n, Hisham. Very good. Okay, so I will have 8. Okay, the 0 means you can think of 0 as true and 1 as false, or you can think of 0 as false and 1 as true. It's up to you. So, okay, Ali, no, I meant rows. Okay, so we can start filling it out. I will take 0 as T. So T, 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 F, T, F, T, T, F, 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 T, T, F, T, F, 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 T, and F, F, F. Okay, so it's very important you do not miss anything. So make sure nothing is missed. So if you follow this tertib of binary, you will not miss anything and you will not duplicate anything. You can write it randomly. You can just say TTF, TTT, TTF, FFT, FFF, but that's a random uh, writing of the columns, and there's a chance you might duplicate something. There's a chance you might miss out something. So with this, you will second to last is FFT. Yes, it's FFT, FFT, and FFF. Okay. So now you start filling it out. Yeah, please complete it and tell me what's the last column. Please complete this and tell me what's the last column. TF then all T. TF then all T. TF then all T. TF then all T. Line 2 is F only, others are T. Very good. Okay, so most of you have got it right. So A and B, true, true is true, 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 false, 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 false. So we look at the fourth column first, and then this. So TT is T, TF is F, FT is T, FF, FT, FF. Very good. Yeah. Okay. So that's very good. Most of you have got it. Any questions with this? Okay, so that very good. Okay, so this is a big marks question, one of the big mark questions that you will see in your final and the midterm. So it just requires practice. I could have just shown this to you on the PowerPoint slides, but I prefer doing it, making mistakes on it so that you correct my mistake. If you correct my mistake, you will not make a mistake in the midterm and final. So I can assure you that. So Alhamdulillah, you've understood this. So let's move on. If you can refer to slide 32. Can you see slide 32? Please refer to slide 32. So if you have an expression like this, which one will you do first and which one will you do next? It's something like this. Just in maths, you have something called as precedence. Okay, you'll have to do the multiplication, division first, multiplication next, and so forth. So similarly, you have precedence even in logical operators. Or if I give you this, there is no confusion. If I don't provide you the brackets, it makes it confusing. So when you don't have the brackets, so what do? You use the precedence. We say that this has higher precedence. The not has the highest precedence. So you finish the not first. And then you do the and on the or. So you do this next. You can probably do this first and then this next. And then you look at the implication operators from the left and right. Okay, so slide 32 gives you the precedence of logical operators. So with that, we complete section 1.1. Any questions? In section 1.1, we looked at what is a proposition, and we looked at propositional relations, the operators, and then we looked at the truth tables, and then we looked at contrapositive, inverse and converse. Just like we did the truth table for converse and inverse, you can fill it out very soon, Abdullah, inshallah. We will let you know. Yes, first assignment will come out not very soon. You'll have the quiz first and then you'll have the assignment. Okay, if you're doing with me what I'm doing on the board, the assignment you'll be able to solve in probably 10-15 minutes. You'll be able to complete the assignment. Yeah, and get full marks. So if you're following what I'm doing in the lecture, and if you're doing it with me, you'll get full marks in quiz, full marks in the assignment, and the midterm will be super easy, provided that you don't make mistakes. In the lab, once the lab starts, Abdullah, you will be getting lots of exercises. But if you want more exercises, you can just create problems yourself. Uh, Faisal, it's up to you to create a WhatsApp group. The students, you can collaborate with each other and you can create the WhatsApp group. In fact, you can give each other problems. If you can give each other problems and challenge each other to solve it, it will help you understand it better. So we looked at this. We know the truth table for if P then Q. Okay, find out what this is. Okay, so you will know. Okay, Hisham has given a number, so please coordinate with Hisham and you can follow form a WhatsApp group. Okay, so find out if P then Q, if it's the same as the contrapositive, as the inverse, as the converse. So you can fill this table out yourself. Or if you want more practice, you can create an expression yourself. You can make your expressions, which is pretty easy. So this is something you just made up. You can share this on WhatsApp and you can compare your answers. Or another good source is the textbook. There are lots of exercises in the textbook that you can try solving. So let's move on to section 1.2, applications of propositional logic. Are you all on have access to the slides? We are on slide 35 now. Slide 35, translating English sentences. Okay, please keep a copy of the slides, because Blackboard, if I switch between white screen and the slides, it takes quite a lot of time. So I usually ask the students to refer. So translating English statements, slide 35. You will be given an English statement and you'll be asked to convert it into propositional logic. So we will be giving you a statement like this: if I go to Harry's house, or to the country, country means village here, I will not go shopping. So we will give you something like this in the midterm and we'll say convert this into propositional language. So what do? You try to break it up. Okay, so how will you break it up? There are two statements. So I have an if statement, if and then. So I'll definitely have something like this. Okay, if I go to Harry's house or to country, then I will not go shopping. So there is an or also. There is an if and then, and there is a or, and there is a not. So I have these. So I can put a not on the right hand side, and then I have a or. Okay, I try to break it up into different pieces. Okay, then I go to Harry's house. So I have, if I go to Harry's house, and then or go to the country. So I can call this H. Go to Harry's house as H, or P or Q, whatever. Go to the country as C. Go shopping S. So not shopping, this becomes not S. Go to Harry's house H. Go to the country. So this is my expression. Okay, you'll have very good, Ali. Very good. Okay, so Ali has given a different solution. He said not shopping. So you can either do this, or you can say, for example, you can say S, but in this case, S means not shopping. Okay, here S means shopping. So if you consider S as shopping, then you use the not S in this expression. If you use S as not shopping, then you'll have just S without the not. So both are okay, both are good solutions, but this is the preferred one, where you've broken it down into the smallest one. So both are okay. So is this clear? Converting English to propositional logic. Okay, so let's move to slide 36. Slide 36 has another example. You can access the internet from campus only if you are a computer science major or you are not a freshman. Okay, you can access the internet from campus only if you are a computer science major or you are not a freshman. The first thing you should do is, over here you have only if. This is the dangerous part. You have a statement, only if, and a statement. So you're familiar with if and then, right? So you have a big statement here and a big statement here. But you're used to writing if something, then something. So when you see statements like this, try to convert that first statement into something as the second statement. So if you remember, long back, we had looked at a slide with different versions of if and else. It is slide number 18. If you go to slide number 18, you have only if. Yeah, slide 18. So you can safely translate this as this. So this means this. P only if Q is the same as if P then Q. Okay, if there are, if it contained when, then you had to flip the statement. But now you don't need to flip. The first portion is still P and the second portion is still Q. So this 18 is helpful. The slide number 18 is very helpful. So you had to go back to 18 to rescue you from this statement. Now coming back to 36, now we can solve it. Okay, you can, if you can access the internet from campus, then you are a computer science major or you are not a freshman. So now it's easy. If you can access the internet from campus, so you can say A is accessing internet from campus. If I can do that, then you're a computer science major or you are not a freshman. Not a freshman. Okay, so this is another example of translating English statements to propositional logic. Is this clear? Slide 36. Okay, good. Let's move on. Another example in system specifications. It's not only Harry and others, but sometimes we use this Not sometimes. A good programmer will use propositional language when translating a system specification. So there's an example given. The automated reply cannot be sent when the file system is full. Okay, so we have something, when, something. Okay, so we are not familiar with this. So again, we go back. We go back all the way to slide 18. So what does it say? Yeah, very good. So if you want to write it as if something, then something, we'll have to flip it. So we'll have to bring this here and move that here. So A is here and B is here. Okay, very good. So we'll have to rewrite that statement to solve this. Just to make ourselves comfortable, we convert it. Okay, so when we convert it, it will mean if the file system is full, then the automated reply cannot be sent. So if the file system is full, then the reply cannot be sent. Okay, is that clear? Okay, so slide 38. Let's look at slide 38. Okay, don't worry about anything. You have just look at the bullet points. You have 3 bullet points. Just focus on the bullet points. Abdullah, I'm sorry, I saw your message after I deleted the slide. Okay, so we had when. We have something, when, something. Okay, so we are not familiar with when. We are not familiar with when. So I want to convert this into an if and else. If then. So I want something, if something, then something. Okay, so in English, this means this, when, these two mean the same thing. Okay, the slide 18 helps us to understand that these two are the same. So the first portion is not always P. You just have to understand the first, whenever is mentioned, is not always P. You will have to look at slide 18 to understand the English portion. If there is a when or otherwise or sufficient condition for, so in those cases, you use the slide 18 and translate that English statement to an English statement which you understand. Okay, this is generally something that we don't usually use. This It's simpler for us to understand this. If I like the chocolate, then I will eat it. If I'm not sleeping, I will come to class. So we don't say that come to class if when I'm sleeping. It's makes it a bit more uh, challenging to frame the sentence. So it's just that these statements are the same. Just understand that. Okay, so how do we translate those 3 bullets? We say the diagnostic message is stored in the buffer or it is retransmitted. So we have it is either stored in the buffer. We can just say stored as S. So it's stored in the buffer or it is retransmitted. Okay, this is the first one. Second one is not stored in the buffer. And the third one is if the diagnostic message is stored, then it is retransmitted. So you have 3 statements. Okay, diagnostic message is stored in the buffer or it is retransmitted. The second is it is not stored in the buffer. Third one is if it is stored, then it is retransmitted. Okay, so propositional logic helps us to understand these things easily. Okay, now let's look at the remaining portion of the slide. So we have this. How do we find out if it's consistent or no? So let's add the fourth statement, uh, the fourth bullet. The diagnostic message is not retransmitted. So we have not T. Okay, now we have four statements. Now I want you to look at those four statements. Okay, these four statements are something. Don't look at the slide now. Don't look at the slide. Just look at the whiteboard. Okay, so I have four statements that the customer has given me, and because the customer is truthful, so this is also true, this is also true, this is also true, this is also true. All statements he's given me are true. Okay, is this clear? Okay, so all statements that the customer has given are true. Now let's look at the second statement. If this statement is true, is the message stored or not stored? Okay, he's saying the message is not stored, which means S has to be, yeah, so S has to be true. For not S to be true, I'm sorry, S has to be false. S has to be false. Because of this, S has to be false. Only if S is false, not S is true. Okay, if S is false, not S is true. What do you say about T? Is T true or false? This T. For this fourth statement to be true, T has to be false. Only for us, if T is false, then not T is true. You get it? Okay. For this to be true, for not S to be true, S has to be false. Okay. For not S to be true, S has to be false. For not T to be true, T has to be false. You get it, Hisham? Okay, so from statement number 2, I find out S has to be false. Statement number 4, T has to be false. Okay, now let's look at the first statement. The first statement says S or T is true. The first statement says S or T is true. But here we have S is false. We found out T is false. Can this be true? False or false? No, it cannot be true. So there is some inconsistency. There is a problem. The customer says S or T is true. He says not S is true. He says not T is true. How can it be possible? How can the fourth statement be true? How can this statement be true? How can this be true? There is some inconsistency. There is something wrong. How can false or false be true? So you go back to the customer and say there's something wrong. Something. He'll say, how? My English statements are correct. You say, no, I converted it into propositional logic and I can clearly understand that there is some confusion. You're saying S is false, you're saying T is false, but you're saying S or T is true. So there is some problem. And then he will go back to his English statement and they'll say, oh, yeah, I had made a mistake. So propositional logic, in a very simple way, helps you to understand if there are inconsistency in specifications. So you will not see 3 or 4 statements, you will see hundreds of statements from the customer. And it's very difficult to look at the English and find out if there's a problem. But if you convert the English to propositional logic, it makes it simpler for analysis. and you can identify inconsistencies. If you don't understand this particular slide, don't worry. You will We will be revisit this later on in 1.6 and 1.7. But for now, just understand that propositional logic can help you identify inconsistencies in system specifications. So that's the objective of this slide. For those who understood the slide, good. For those who didn't understand, no problem. We will be revisiting this in section 1.6 and 1.7. You will understand it better at that time. So is this clear for now? So we looked at truth tables today, and we looked at proving equivalence, so finding how they are equivalent, and we started off with 1.2. 1.2 is just applications. It's basically how will you apply propositional logic in which places. So the first place is to understand converting English statements to propositional logic. The second application is to find out if there are consistencies or inconsistencies in system specifications. Inshallah, the next few slides we will continue in the next class, but that's all for today. Ali Habib, kind of yes is good. If you didn't understand it completely, no problem. We will understand by the end of this chapter, you will understand these slides. After 1.6 and 1.7, this will be a very simple slide for you. But the main focus of today's lecture was on the truth tables, and we also looked at the precedence of operators, and that's all that was the focus of today's lecture. Okay, with that, I will stop the lecture and the recording. Those who wish to leave can leave. Those who wish to stay and chat and create the WhatsApp group can create. And those who wish to see me, you can send me an email requesting for an appointment at your convenient time. That's all for today. Assalamu alaikum wa rahmatullahi wa barakatuh.